Okay, everyone, so let's recap what we know so far. So, Democritus and Dalton had essentially the same type of model. So we have a billiard ball spherical model with nothing inside, like it's dense and solid. Then we had Thomson, where we have little negative electrons, and he hypothesized that the sphere was positive, right? So here's our kind of timeline. So this was Democritus and Dalton, and then we had Thomson, and now we're going to come to Rutherford. So Rutherford, again, I'll have a video linked to how this experiment was done in more detail, but essentially, Rutherford took a very thin piece of gold foil. So imagine like aluminum foil, the thinness of aluminum foil, but using gold. And what he did is he used an alpha particle emitter. So the only detail you really need to know about alpha particles is the fact that they are positively charged. Okay, so what ended up happening is he basically shot or had a beam of these positive charges, and he essentially aimed it at this a gold foil leaf. So what ended up happening, actually the zoomed in kind of artist rendition is here. So these are representing our gold atoms. So you have to remember, up to this point, it was hypothesized that this was the model of the atom. So what he was trying to prove here with this experiment is, just like Thomson decided to do negative and prove that they repelled, he wanted to do the same with positive charges. Now, what he found is, and these arrows are representing the positive particles, most of them actually went straight through the foil. Okay, so that was actually a very big discovery. So what that proved is that atoms are mostly made up of empty space. If there was no empty space there, that means that all of these particles would be deflected off because it wouldn't be able to go through. But most of them were able to go right through the foil. So again, that proved that there was empty space there. Also, every once in a while, I'll use a different color here, there were particles that deflected. Excuse me. So what happened is, what he believed and what ended up being true is that there had to be something positive inside of the atom that was deflecting or pushing away the positive particles, just like Thomson discovered with the negative and negative. So the atoms were mostly empty space, but there was also a tiny dense core that had a positive charge. So now we know that most of it is empty, but there is something in the middle that has a positive charge, because every time a positive particle went near it, it basically was pushed away. So that positively charged center is called the nucleus. So Rutherford's main discovery was the fact that the atom now has a nucleus and is made up of mostly empty space. So let's take a look at let's add to our picture. So for Rutherford, this is also referred to as the nuclear model. Basically, we have a positive center of the different charges. So that's our nucleus. And what he believed is, so instead of having the electrons anywhere in the atom, like a chocolate chip cookie, he believed that the atoms had a positive center and that the negatives were randomly around, which is exactly what this is here. So here's kind of a summary of what was discovered. So we know that the nucleus is small compared to the size of the whole atom, and it's dense. Okay, now in the nucleus we have positive charges, which he later named protons, and the fact that those negatives that Thomson discovered were not kind of anywhere in the atom, but they were outside of that positive sphere. So that positive center of the nucleus that has protons in it, and then the negative electrons were scattered around where that positive center was. Okay, so then we get to our last main scientist here, who is Niles Bohr. So essentially what he did is he took the idea of Rutherford and basically wanted to look a little bit more in depth at the electron placement. So let's go back to like our summary page here. So here we had Rutherford. So the next person, basically we still kept that positive center. Okay, the nucleus is still true. But we wanted to look more at, instead of the electrons being randomly scattered, that maybe there was an actual placement for these electrons of how they were, how are they located around the nucleus. So in his model, he proved that the electrons move around the nucleus in an orbit. Okay, so these orbits go by many names. So we can say orbit or energy level or shells. Okay, usually we use the term energy levels, but either of these are acceptable. So instead of being randomly scattered, electrons are actually in orbit around the nucleus. So just like how planets orbit around the sun, so imagine this is an electron, the electron would basically go around the nucleus. And you can have electrons on the same orbit, or you can have electrons on a different orbit. We're going to look more in detail about how these orbits are set up later on in this unit. But what you need to understand is that Bohr's main contribution to the atom is the fact that we now have these energy levels. So going back to this, now instead of having the electrons randomly around, we now have the electrons in orbits. So I'm just going to kind of just draw, I mean, you can have different numbers of electrons here. I'm just going to draw a few for an example. So this is Bohr. So every scientist has kind of its main contribution. So of course, Democritus and Dalton is the atom in general. Thomson is the electron. Rutherford is protons and the nucleus arrangement. And Bohr are the energy levels for our electrons. Okay, now the last scientist kind of unfortunately, it's not really known as one of the main contributors, but there is something to be said about James Chadwick. So essentially what he discovered is that the nucleus does not only have protons in it, but the nucleus also has a particle in it called a neutron that is neutral, and that's actually where it gets its name from. So it has no charge. So let's make a summary chart. So we have protons that are positively charged. We have, I was writing negative. We have electrons that are negatively charged. And we also have neutrons that are neutral. They have no charge. So protons and neutrons are found in the nucleus, which is that center dense part of the atom. And electrons, we now know, are in energy levels or orbits or shells, energy shells, whatever you want to call them. But they are around the nucleus, right? So essentially we now have, protons and we have neutrons in the middle, and we have our little negative electrons on the outside. Okay, so that's essentially it for the atom. We're going to go in more detail of how to draw these later on. But that's essentially it. And those are our diagrams here. Let's go through this. Okay, so so Chadwick doesn't have his own picture, but basically Chadwick contributed by adding neutrons. So that was Chadwick. Neutrons were added into the atom.